The following video is intended as a little tutorial on how to calculate empirical formulas based on percentages given in the problem. Going from grams instead of percentages is really not any simpler as we start this. I got these listed out in a series of steps which you've taken in class in your notes, and it's just a matter of applying those particular steps. Step 1. Assume you have 100 grams. If I have 100 grams of this unknown compound and I know what the percentages are, essentially what we're saying then is that 27.93 grams is iron and etc. for all the other compounds. So all we're doing is changing these percentages to number of grams. Once we have the masses, and if you're given a problem that starts with masses, you don't even have to do the first part. You go straight to number 2 and you perform the mole calculation. So I have the number of grams of each of my substances, so we need to set up conversion factors. As I show my students, I set up parentheses. Some people use T-charts. I like to use parentheses. It's more mathy to me. I have grams on the outside. Units drive the conversion factor, so what unit goes on the bottom of the conversion factor? Hopefully you said it was grams. So grams goes to the bottom, and with the number grams goes the molar mass of whatever element we're dealing with. So here I have iron. So I look up iron on the periodic table, and its mass is 55.85 grams is the unit to mathematically cancel. I do the same thing for sulfur. Look up sulfur on the periodic table, 32.07 grams on the bottom. Grams cancel. Do the same thing with oxygen. So grams goes to the bottom. I want to convert to moles. So moles goes to the top of these. And we're doing molar conversions. 1 always goes with moles. So now we're ready to do some calculations. And if you want to use a calculator to play along, you're more than welcome to. For the first one, you get about half a mole. And for sulfur, you get about 3/4 of a mole. And for the third one, you get almost 3 moles. Now, at this point, these numbers are actually part of your empirical formula. We could write an empirical formula, Fe.5, S.75, O2.8. But of course, when we deal with formulas, when we think about atoms, these are again in moles. Perfectly fine to think of them in moles. But when we think about atoms, you can't have half an atom. You can't have 0.7 of an atom. So we want things in whole number ratios. We want our simplest whole number ratios. And that's where steps 3 and 4 come into play at. But already we have a basic formula here for what we have. All we got to do is make them look at sensible numbers now. And that's where step 3 comes into play. Step 3, I teach the class divide by the lowest number of moles. Well, my lowest number of moles is 0.5, so I'm going to divide all 3 of these numbers by 0.5. So I'm going to pull all these numbers off of here. We're going to do a simple division of them. Bring that back up, and we're dividing them all by 0.5. This is putting things now in lowest common terms. So how many irons do I have? Well, that's easy. That's 1 iron. How many of these do I have? Well, that's pretty easy too. That's 1.5 sulfurs. Not a whole number yet, but we'll get there. And the last one, I get about 6. Now, I do want to show you what my calculator shows when I did that calculation. Let me bring my calculator over here, and you see here I have this. It's 5.96. That's close enough to 6. There's going to be some rounding errors in here. So we're going to call that 6 oxygens. So at this point in time, I now have the formula Fe1, S1.5, 0.6. But I'm dealing with the same issue as I had right over here. They're not simple whole number ratios yet. They're not wholes. S is a 1.5. I can't have 1.5 sulfurs. I either have 1 or I have 2 when you talk about the atoms part. So in the last part, we have to multiply all of the subscripts by an integer where I get all whole numbers. So if you think about it, what can I multiply all these? Remember, there's an invisible 1 behind iron. Well, I think you should come up with the idea that you multiply by 2. If I multiply everything by 2, the 1.5 becomes 3. So I double the entire compound. I now have Fe. There's now 2 of them because I doubled it. Remember, the invisible 1. 1 times 2 is 2. 1.5 times 2 is 3. And I double my oxygen, and I get 12. So my empirical formula, in its correct form, is Fe2S3O12. Now, the only thing about this is it's really not written out correctly yet. We can go one step further, and the one step further comes into looking at the S and the O and realizing, oh, I probably have a sulfate, SO4, or a sulfite, which is an SO3. and I notice I got a 3 and a 12. Both of those are divisible by 3, so I can imagine factoring the 3 on the outside. And when I factor the 3 on the outside, that leaves me with an SO4 in here, because 12 divided by 3 is 4, 3 divided by 3 is 1, and I factored my 3 out here. So the best way to write this formula is Fe2 SO4 in parentheses 3. On this form, Fe2S3012, I can't really name that yet. But over here I can name this because I've identified my polyatomic ion of sulfate. So this particular compound right here, if you're naming it, is iron. We do a reverse crisscross. This is iron 3 sulfate. So again, in review, there's 4 simple steps, and once you learn the steps, it's all pretty simple. You basically take your grams, you convert them into number of moles, then you divide everything by the lowest number of moles to put it in ratio, small number ratios. And at the end, if I have any 0.5s or technically you could probably do thirds, multiply things by 3 to get rid of that. So 1.33 repeating would be somewhere around a third, but you have to be careful with that. Most of the time you just double things, but there are issues where you don't. And the last step is then multiply by a whole number to get them all in whole numbers. 2 atoms of iron, 3 atoms of sulfur, 12 atoms of oxygen. And then this answer is not wrong, Fe2S3O2. It's just not written in the best possible way. The best possible way is my iron 3 sulfate here, written like this. If you have any questions, you can email or ask me in class. Thank you for your time.